dihybrid cross. But the final step is the step that you need to pay the most attention to. If you rush through this step, you're almost guaranteed to get this problem wrong. So please don't rush. Make sure you have double checked everything, crossed your T's and dotted your I's. So please, please, please do not rush. Alright, so we have determined the parent's gametes by using FOIL. We have set up our dihybrid cross. We have completed the cross, and we have figured out all of the possible genotypes that an offspring could inherit from its parents. Now we need to figure out the probability that those genotypes are inherited, and then the probability of those offspring having a specific phenotype. So what we need to do is we need to go through and determine all the possible genotypes that are within this dihybrid cross table. So what I like to do is I like to always start in the same place, right here in the upper left-hand corner. And we're going to go ahead and we're going to put a big X in this box, stating that we have in fact looked at this box and we have tallied it and the genotype that it codes for. So down here, one of the possible genotypes that an offspring could inherit is big L, big B, little b. And so far, we have a total tally of one possibility of an offspring inheriting that genotype. Now we need to go through and look through all of the other boxes and see which other ones read big L, big B, little b. And for each one of those, after we read it, we need to put an X inside of it, and we need to include it in our tally marks down here. So here's a second possibility, so add that to your tally mark. Here's a third possibility, add that to your tally mark. Here's a fourth, add that. Alright, this row also reads big L, big B, little b. So add that to your tally mark. Add that to your tally mark. Add that. And add that. Alright, so far I've looked at 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. They all have the exact same genotype. They all have an X in them, stating that I have in fact looked at that and I have included it in my tally down here. Let's go ahead and make sure I have 8 tallies. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so far I've double checked everything, and I have a total of 8 out of 16 chances that my offspring will be big L, big B, little b. 8 out of 16, if you know your math, is 50%. Okay, another possible genotype is right here. Big L, big B, little b. So that is a second possibility. Big L, big B, little b. And we need to include a tally mark. This one also reads big L, big B, little b. Put an X in there, tally mark. And go ahead and count all of the ones that have big L, big B, little b. This entire row should. And if you look here, this entire row also has big L, big B, little b. This entire row is heterozygous for both traits. So I need to put 4 more tally marks down here. 1, 2, 3, 4. Okay, so let's go ahead and count up these tally marks. 1, 2, 3, 4, 5, 6, 7, 8. Again, 8 out of 16 boxes have the genotype that is heterozygous for both traits. That means that my offspring have, again, a 50% chance of being heterozygous for both traits. And they also, as we found earlier, have a 50% chance of being homozygous dominant for fur length and heterozygous for fur color. Okay, now we want to figure out what is the probability of them having a certain genotype. Okay, so, or a phenotype, I'm sorry. So the big L, big B, little b codes for long fur and gray fur. Okay, and big L, little l codes for long fur, and big B, little b codes for gray fur. Okay, so this is interesting. Although we have two separate possible genotypes that my offspring might inherit, both of those genotypes code for the exact same phenotype, long and gray fur. That means that regardless of the genotype that they inherit, there's going to be a 16 out of 16 chances that they're going to have long and gray fur, which translates into 100% chance of having long and gray fur. This is a relatively simple problem. Ratios are not always going to look as pretty as 50%. Sometimes you can see 9 to 3 to 3 to 1. You can see things like 4 to 4 to 4 to 4. There are many, many different possibilities out there. So don't expect it to always look this pretty, but you need to follow those basic steps. At this point, you've successfully tracked the inheritance of two traits. Congratulations, and keep on practicing because it gets more difficult.